Okay, grade 8, this is your probability unit. These are all of your questions from the probability unit. They get progressively easier or progressively more difficult. We start easy, we get more difficult. So the first 6 or 7 questions that you do here all have to do with your grade 7 understanding of probability. They have to do with table of values and or table and tree diagram. So the first question says John flips a coin and rolls a 6-standard die. What does this mean? Well, the P stands for probability. It means probability. And H3, the first letter stands for the first event, in this case flipping a heads. And the second letter stands for whatever the dice is, which is rolling a 3. So probability is calculated by taking the favorable outcomes, or what we're looking for, favorable outcomes, and dividing them by the possible outcomes. So if I wanted to know what's the probability of a heads 3, I'd have to first figure out what are all my possible outcomes. So down here I could put heads and tails. Those are the possible outcomes for flipping that coin. And up here I'd have a 1, a 2, a 3, a 4, a 5, and a 6 for the 6-sided dice. So in here we have all the possible outcomes. Of all those possible outcomes, this one would be a heads and a 1, a heads and a 2, a heads and a 3. So if we look at all of our outcomes, we have 12 different outcomes, which are your possible outcomes. They're the possible outcomes. And what I'm looking for, this is called your favorable outcome. In heads 3, there is only one of them out of 12, which means the probability that I'll flip a head and roll a 3 is 1 out of 12, which if I take my calculator and bring it over here, 1 out of 12 is 0.083 repeating, or 8 1/3% chance that will happen. In the second example, it says, what is it? Use a tree diagram to represent the sample space. So this time my first event is a head or a tail. And the spinner gives me 3 choices, either 1, 2, or 3. And if it was a tails, it could be a 1, 2, or 3 for that as well. So my sample space is the end of each of these branches. A heads with a 1, a heads with a 2, and a heads with a 3 are 3 choices up here. And down here we have a tails with a 1, a tails with a 2, and a tails with a 3. So there are 6 possible outcomes. And the probability of a heads 2, only one of them at a 6, which is 0.16 repeating, or 16 2/3% probability. Your fourth or third question says what the following tree diagram represents the sample space. So this means you can have a TWO on the first spin, and if it was a T on the first spin, it could be a TWO on the second spin. So a TWO on the second spin, if it was a W on the first, you could have a TWO on the second spin, and so on and so forth. So if we look at the end of each of these, there are 9 possible outcomes. The sample space would look like this. There are 9 possible outcomes, and they're listed all here in the sample space. And of those, the one that is tails and W in that order, there's only one. Now, some might argue that this is also a tails W, but it's actually W tails, which is the opposite of it. But you could, if it was in any order, you could say 2 out of 9 if you didn't care what the order was. And finally, the probability that both letters are identical. We have 1, we have 2, and we have 3. 3 out of 9, which is 33% probability. 33 1/3. Question 6 is Ali draws a card at random from the set of 5 cards pictured. So if I was to do my table of values, I'll put my cards up here, the 3, the 4, the 5, the 6, and the 7. Those are my cards. And my dice, 1, 2, 3, 4, 5, and 6. So my sample space clearly says that there are 30 possible outcomes. And the probability that the same number is on the outcome of both the card and the dice, if I take my little thing here and put, well, there's a 3, 3, there's a 4, 4, there's a 5, 5, and there's a 6, 6. There are 4 chances out of 30, which we can convert to a percentage if we wanted. The probability that the sum of the two numbers is even, So the sum of the two numbers is even. I'll use my green marker for this one. So 3 and 1 is 4. That's even. 5 and 1 is 6, and 7 and 1 is 8. 4 and 2, 4 and 6. All these ones we have circles in. If we was to put the sum of them in there, we would have even sums for all of those. So there's 5, 10, there's 15 out of 30, which I think most of us know is a 50% probability. And finally, what is the probability that the number on the die is equal to or larger than the number on the card? Probability on the die. So here's my dice here. So equal to or larger than. So if it was 1, there are no numbers there. But if the dice was 3, this would be equal to or larger, but none of the other ones would be. If it was a 4, if this 4 was here, this and this would be larger. If it was the other one, 5 would be larger than 3 and 4, and it would be the same as 5. And if it was a 6 on the dice, it would be larger than the 3, the 4, the 5, and it would be the same as the 6. So we have 4 plus 3 is 7, 8, 9, 10 possible outcomes out of 30, which most of us also know is 33 and a third % probability. Question 7 says Lucy is jiggling the fish through the ice. So if I take my pen and I was to say that she can catch a whitefish, a trout, an Arctic char, or losing the fish equally, up here I'm going to put W for whitefish, T for trout, AC for Arctic char, or 0 for none. Then I would do the same thing for the second time she jigs, and I would put them there. Therefore, I can clearly see inside here there are 16 possible outcomes. And what is the probability that it's a whitefish char in either order? Well, whitefish char would be there, and Arctic char whitefish would be there. So that's 2 out of 16, which I believe is 12.5%. What is the probability of char char? Char char. Char char binks. There was only one part out of 16, which would be 6.25%. And what's the probability she will catch nothing at all? Same as char char. It's 1 chance out of 16. For question 9, it says 2 babies were born today. Construct a table to show the possible outcomes. So we'll put baby 1 up here. That can be a boy or it can be a girl. And the second child could be a boy or a girl. So there are 4 possibilities for the 2 boys, or for the 2 babies. They can be boy boy, they can be boy girl, they can be girl boy, or they can be girl girl. What's the probability that there was 1 boy and 1 girl? There are 2 of them that are 1 boy and 1 girl, which means 2 chances out of 4, or roughly 50% probability. The next one is a spinner is divided into 4 equal regions. The spinner is spun 3 times. Draw a tree diagram to show the sample space. So for this one, because it's spun 3 times, I'd have T, N, E, E. Then I'd have T, N, E, E. I gotta make it bigger. I don't have enough space here. Let's do that again. I'll press pause and draw. So once my tree diagram is done, I now have, so this one here would be a T, a T, and a T. This one would be a T, and an N, and so on and so forth. So if I was to look at the end of each of these branches, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 outcomes there. I have 4 16s, which would be 16 and 2 is 32. 32 and 2 is 64. There are 64 possible outcomes for this question. I can't even remember what the question is anymore. It says, what is the probability of P? Oh, sorry, that's not P. That's P-E-E-E. So if I go back and look at the P-E-E-E, the probability of an E, oh, I made a mistake here. This is supposed to be an N here, and an E here, and an E here. So the E-E-E, there is 1 there. There is 1 here. There's 1 here, and there's 1 here. That's 1, 2, 3, 4 of them here, and there's 4 of them here, if I could extend that over there. So that is 8 parts out of 64, which in lowest terms is 1 part out of 8, which is a percentage. There's a 12.5% chance of doing EEE. And finally, what's the probability that one letter, the probability that one letter appears exactly twice? Oh, great googly moogly. Exactly twice. So TTT would not. I'll use green. Why not? TTN would be. TTE would be, and TTE would be. TNT is not. Oh, yes, it is. TNT is. Because T appears twice. TNN is. TENE is not. No, TNE. No. TET. Yeah, that one does. TEN. No. TEE. Yeah. TEE. Yeah. TET. Yeah. TEN. No. TEE. Yeah. And TEE. Yes. Holy snapping Archibalds. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on this one. This one. And that one there would be. That one wouldn't. That one wouldn't. This one would. That one wouldn't. This one would. This one would. That one wouldn't. This one would. This one would. This one would. Oh, man. This one wouldn't. This one would. This one would. This one would. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this one. E-T-T would. E and no. Yes and yes. Oh, great googly moogly. Yes. Yes, yes. Yes, yes. No, no. Yes. Yes. No, no. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 in this one. There's also 10 in this one. Did I miscount over here? Is there only supposed to be 10 over there? Does anyone know? 4. No, that looks right. That's right. So there should be 41 chances out of 64 that you will have two letters the same, which as a percentage. 64%. Now, if it happens to be 40, and I made a mistake, you'll get 62.5%. But either way, it's around 60-some percent. Okay, and the last question of this first section says Alena rolls 2 6-sided dice. What's the probability that the difference between the two numbers is 2? So if I make this chart, and I figure out the difference between the two numbers, the difference between a 1 and a 1, difference means subtract. So if I subtract those two, the difference between a 1 and a 1 is 0. The difference between a 1 and a 2, I can either think of as a -1 or a 1. I'm just going to go with the larger number first. So these would be the differences if I subtract the smaller number from the bigger number. These would be the difference of the bigger number, take away the smaller number. This would be the difference here. This would be the difference here. This would be the difference here. And so on and so forth. 4, 3, 2, 1, 0, 1. And 5, 4, 3, 2, 1, and 0. So the difference of the two numbers is 2. I would have 1, 2, 3, 4, 5, 6, 7, 8 numbers out of all of those, which is 36. So 8 out of 36, which as a percentage is roughly, oh, that's an interesting one, 22 and 2/9%. 22 and 22/9, or 22.2 repeating percent. What's the probability that the sum is a multiple of 3? So this time I'm going to take my green marker, circle all of the sums. Oh, the sums I don't have. Oh, great googly moogly. All right, hang on a second. What I'll do is I'll infinite clone this. Just hang on a second. So this time I'm going to put my sums inside there. So the sum is a multiple of 3. So the sum is 2, 3, 4, 5, 6, and 7. If I fill it all in. So if I put the sum of the two numbers each way through there, I have this table made up with all of the sums or the two numbers added together to make those. What is the probability that the sum is a multiple of 3? Well, I'll circle the ones that are multiples of 3. All of those ones I circled are multiples of 3, which means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36, which in lowest terms is 1 out of 3, which is roughly 33%. Now, so your last question here says, what's the probability the product is a multiple of 4? So what I'm going to do is put the products of all of them inside here. So if I put the products of each of those inside the squares and ask myself which ones are multiples of 4, this time I'll use my blue marker. 4 is a multiple, or that's not blue, that's green. 4 is a multiple of 4, so is 4, so is 8, so is 12. 12 is 4, 8, 12, 16, 20, and 24 are all multiples of 4. 20 is a multiple of 4. 36 is a multiple of 4. 24 is a multiple of 4. And 12 is a multiple of 4. Did I forget any? I don't think so. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of 36 are multiples of 4 when I multiply the two numbers together, which if I convert that to a percentage is roughly 41 and 2/3%, or 41.6 repeating.